What is magnetic susceptibility? Very important concept to understand. Susceptibility. So magnetic susceptibility is denoted by a term called chi. We can observe here the magnetic field lines are repelled from each other. So we can observe the repulsion between the field lines when a bar of diamagnetic material is placed in an external magnetic field. But the magnetization varies from one domain to another domain, and the net results of assembly of domain size is 0. Hello everyone. Welcome to session 2 of chapter 5, Magnetism and Matter. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the last session, we have learnt about a brief introduction about the terms which are related with magnetism. In this session, we are learning few more interesting concepts. Let's begin with the terms related to magnetism. So to understand the behavior of magnets or to understand the characteristics of magnetic property of substances, we need to understand the terms which are related with the subject. So we have magnetic intensity. What do you mean by magnetic intensity? We generally know what the intensity is. What is a magnet? We have learnt in the last class. So now we are learning magnetic intensity of any material is a ratio of external magnetic field to the permeability of free space. So magnetic intensity is denoted by H, which is equal to the ratio of external magnetic field to its permeability of free space. So this magnetic intensity is a vector quantity. What is the SI unit? It is ampere per meter. So next term which is very important to understand is magnetic permeability. We are familiar with the term called permittivity. Permittivity of free space, permittivity of a medium. So we have learned this in electrostatics. In magnetism, we have a term magnetic permeability. So the ability of substance to allow the magnetic field lines to pass through it is called as magnetic permeability. Which means if I have a substance, what are the number of lines which is passing through this? So the ability of allowing the number of field lines to pass through a surface is called as a magnetic permeability. So the magnetic permeability of any substance is equal to the ratio of magnitude of magnetic induction, that is B, to the intensity of magnetizing field, that is H. So it is denoted by mu. Mu is magnetic permeability, which is equal to the ratio of magnetic induction B to the intensity of magnetizing field, that is B divided by H. Now we know about magnetic permeability. Let us understand what is a relative magnetic permeability. So the ratio of the flux density inside the material. What do you mean by flux density? It is nothing but the number of magnetic field lines inside the material to the flux density in vacuum is known as a relative magnetic permeability. We know generally magnetic permeability is number of field lines, the ability of number of field lines to pass through the substance. So the ratio of the magnetic flux density inside the substance or inside the material to the flux density in vacuum is known as the relative magnetic permeability. It is denoted by mu r, where B is the flux density in the material and B naught is the flux density in vacuum. So let us substitute the term which are involved with B and B naught, which is equal to mu H, which we have studied here. B is equal to mu into H divided by mu naught into H, where H and H gets cancelled and we remain with mu divided by mu naught, and this is called as relative magnetic permeability. It is a dimensionless quantity. What is magnetic susceptibility? Very important concept to understand. Susceptibility. So magnetic susceptibility is denoted by a term called chi. It is the ratio of magnetization developed in a material to the magnetic intensity. We know what is magnetization. So it is denoted by capital M and the magnetic intensity is nothing but H. So the ratio of magnetization developed in a material to the magnetic intensity is nothing but the magnetic susceptibility. So it is just a number. It has no unit. Now we have learnt about the various terms involved with magnetism concept. Let us now understand on the basis of external magnetic field what is the behavior of materials, how it is categorized. So the materials are categorized into three types, that is diamagnetic materials, paramagnetic materials and ferromagnetic materials. So let us learn in detail about these materials. What is diamagnetic materials? So what kind of materials, when it is placed in the external magnetic field, will be strongly magnetized, or what is the material type which gets weakly magnetized when they are placed in magnetic field? Let us learn. So the diamagnetic materials, our first category is diamagnetic materials. When these materials are placed in external magnetic field, they get weakly magnetized, that is in the direction opposite to that of external magnetic field. So the magnetization direction will be opposite to the external magnetic field in case of diamagnetic materials, and they get weakly magnetized when they placed in external magnetic field. So these materials, they feebly repelled by magnets, and they tend to move from a stronger magnetic field to weaker parts of magnetic field. So these type of materials, we call them as diamagnetic materials. What are the examples for diamagnetic materials? Example, bismuth, copper, zinc, silver, gold, hydrogen, mercury. So these are all the examples for diamagnetic materials. Suppose this is a bar of a diamagnetic material. So when a bar of diamagnetic material is placed in external magnetic field, we can observe here the magnetic field lines are repelled from each other. So we can observe the repulsion between the field lines when a bar of diamagnetic material is placed in an external magnetic field. We can also observe that the magnetic field inside the material is reduced when a small part or a small piece of diamagnetic material is placed in a non-uniform magnetic field. If it is placed in uniform magnetic field, these are our observations. When the small piece of a diamagnetic material, when it is placed in non-uniform magnetic field, such that the space near the pole of a magnet, it tends to move from stronger magnetic field region to weaker magnetic field region. So the characteristics of diamagnetic materials are, they get repelled, they get weakly magnetized, and we can observe a force of repulsion between the field lines when it is placed in a uniform magnetic field. Let us learn about the next category of material, that is a paramagnetic material. What do you mean by paramagnetic material? So these are the substances, when placed in an external magnetic field, they get weakly magnetized, and the direction is in the direction of magnetic field. So the difference between diamagnetic and paramagnetic is the direction. So direction of magnetization. When diamagnetic material placed in a uniform magnetic field, the substances gets weakly magnetized but in opposite direction. But in case of paramagnetic, it is of the same direction of applied electric field. So best examples for paramagnetic materials are aluminium, calcium, chromium, lithium, platinum, and tungsten. Suppose a bar of paramagnetic material is placed in an external magnetic field, the field lines get concentrated inside the material. We can see here it gets concentrated inside the material, and the field inside the material is slightly increased. When you compare to this, we can see here the field inside the material is reduced, but here it is increased. So this is another difference between diamagnetic and paramagnetic materials. So let us move on to the last category of materials, that is ferromagnetic materials. What are ferromagnetic materials? The substances, when they are placed in an external magnetic field, they get strongly magnetized in the direction of applied magnetic field, which means the materials among these three categories, ferromagnetic substances get strongly magnetized, and also the direction is in the direction of applied external magnetic field. So this type of materials, we'll call it as ferromagnetic materials. Example, iron, nickel, cobalt, and etc. So in case of ferromagnetic materials, the individual atoms, they possess a permanent magnetic field like in paramagnetic materials. However, they interact with one another and align themselves. Say for example, I have a number of atoms in the material. They interact each other and they align themselves. So this interaction and alignment of an atomic particles under a microscopic view, we'll call it as domain. Each domain has its own magnetic moment oriented in its own direction. So we can just understand that by this diagram. You can see here each domain is oriented in its own direction. but the magnetization varies from one domain to another domain, and the net results of assembly of domain size is 0. So what happens if we apply a magnetic field to this domain now? Say for example, when the external magnetic field is applied here to this domain, they tend to align in one direction. They orient in one direction like this. This is in the absence of magnetic field. So whenever the external magnetic field is applied to a domain, so it will try to align in single direction, and the direction is along the direction of magnetic field. So the result of applying magnetic field is the number of domains pointing in the direction of magnetic field increases, and hence the ferromagnetic substance is strongly magnetized as shown in the figure. So these ferromagnetic substances, we know they get strongly magnetized when they are placed in an external magnetic field. So what are the types of this ferromagnetic materials? There are two types. One is hard ferromagnetic materials, the other one is soft ferromagnetic materials. What is the meaning of hard ferromagnetic materials? A ferromagnetic is said to be hard when it is not demagnetized very easily. So when we are not able to demagnetize a material easily, we'll call them as hard ferromagnetic materials, because we know that the ferromagnetic materials get strongly magnetized. The best example to understand this is a steel. What is the meaning of soft ferromagnetic material? A ferromagnetic material that can be demagnetized easily. They are called as soft ferromagnetic materials. Example for this is soft iron. So this is all about the types of magnetic materials, the properties and the terms involved with magnetism and matter. In the next session, we will come up with some more interesting topics. Until then, keep learning all of you. Thank you.